Good evening, everyone. So I have a couple of announcements before we start. So next month's meeting, we have Daryl, who will be talking about his sort of BBC Basic inspired language, Daric, with inbuilt 3D graphics. And then the exciting announcement, our April meeting on April the 19th. I've just updated the ROUGOL website to say we have Sophie Wilson coming to visit us, who will be doing she's offered either to give a talk or just to come along and do a Q&A. So we could just basically quiz her for 2 hours, which may be fun. So that's our April meeting. So put April the 19th in your diaries. The amusing thing about that date is on April the 19th, 2010 was when she actually visited ROUGOL back in London Bridge. So it's exactly 11 years to the day since she last came and spoke to us. So that should be an interesting evening. So look forward to that. Right, so now I'll hand over to Steffen Hoover, who's going to tell us all about the joys and pitfalls of DVD and CD writing.
I'm trying to show you a bit about CDVDBurn 3 and also some other projects I'm currently doing and that are approaching finalization. I keep telling that for years, and hopefully they will be finished soon. So let's go. First of all, sorry for the lack of proper hairdressing. We are still in lockdown in Germany. So the hairdressers only open in March. So hopefully this gets done a bit earlier. Okay, so now let's go. I'm trying to do a two-part presentation. So the agenda looks a bit like that. So first I'm doing the promotion part. So why should you really all buy CDVDBurn 3 if you haven't already? And then that is followed with part 2, hopefully the interesting stuff. Okay, so the first thing I would like to explain is why in 2028 you might still want to handle those optical discs. So there are, in my mind, 3 reasons you might still want to have the opportunity to write optical discs. The first one, most important one, in my opinion, is archiving and backup. And there are a few reasons why optical discs are really good for that. There are really types of media that are quite good for longevity. There are the M disc that is said to be engraved instead of just written. They say it will last probably for 1,000 years. I wouldn't bet on that, but perhaps 20 years, 30 years is good enough for most of us. And there are special archival grade discs that are also renowned for their longevity. The first CD I recorded in 1996 is still readable today. So that is really an example for longevity. I think your average floppy disk or your average hard disk might have some more problems in that respect. So the disks are easy to store. You don't have to have your temperature grade archive room, so you just keep them dry and you keep them in the dark. Direct sunlight is not a good idea, but if you keep them dark, they are really long lasting. One advantage, if you've ever accidentally overwritten your data on a hard disk or on a USB drive or on a SD card, is that the medium is read-only by design. So once written, you'll never delete it accidentally. It is still quite cheap per gigabyte. We're talking about less than 10 pence per gigabyte for quality media. So that is really quite cheap compared to other media. The drives, there are many of them. They are still sold as new. You can still you can connect the drives everywhere. You have still newly made IDE drives. The only thing that's perhaps a bit more difficult is still getting SCSI drives. But you have USB, you have S-ATA, and if the world ends, you still have a supply of PlayStation 3 drives that will keep you going. An important thing is that really every operating system can read your archive, your backup. The format used for CDs, DVDs, Blu-rays is really quite simple. So even if you lost all possibility of documentation for the format, it is really easy to reverse engineer. So as long as you can read the bytes, you will be fine. A second good thing about optical disc is the case of data transfer to classic computers. So the alternatives, maybe you don't have a network card in your RISC PC, or the floppy is just too small for the kind of data you want to transfer. And serial port, null modem cable is really not the fastest thing to use. So there is still an interesting use case for optical discs. And the third thing is writing audio CDs. There's still a lot of classic stereo equipment, car CD players that don't have that newfangled USB or SD card stuff. So this is still an important use case, depending on the equipment you have at home. So for those of you who already have CDVDBurn or CDVDBurn, I'm going to run through the feature set, what's new in CDVDBurn 3. The most important thing is there is now proper support for all RISC OS 5 machines. The previous version, CDVDBurn, worked on the Ionics, but not really well on new hardware, starting with the BeagleBoard. CDVDBurn 3 is compatible with everything from ARM version 5 to ARM version 8, so that covers the Ionics, Raspberry Pi 1 up to 4, and the new 400 and everything in between. So ARMX6, Titanium, Panda board, BeagleBoard, everything. It also still runs on the RISC PC or on an A7000. Later on, I will demonstrate with RPC EMU. The problem is that I have removed drive support because it became a maintenance burden at the moment. I'm still pondering whether to add it back later on. Maybe this is a good feature for the next upgrade. At the moment, it's RISC OS 5 exclusively. If you want to write drives, if you just want to create your ISO image, it is still fine on everything, starting with RISC OS 3.5, possibly even 3.1. So, support for USB, serial ATA, and of course the old Ionics IDE is there and working quite well. Many modern drives are now supported. This was always a bit of a sore point with the predecessor CDVDBurn. There were only very few drives that worked really well. So now I've bought and tested quite a lot of modern drives that are still available today. And there is a list on the website that explains which drives are available, USB and serial ATA. The best working brands are Asus, LG, Lite-On, and unfortunately only one Samsung drive. That's a bit sad because many ARMX6 machines were shipped with Samsung drives, but I was up to now not successful to get this drive working. Still trying, but not much hope. So CDVDBurn 3 is now ready to support all media types. Its predecessor was a bit limited in the DVD department, but now it is really any kind of audio and data CD or CD recordable or rewritable, both are supported. All kind of DVD formats, the minus ones and the plus ones, and the DVD RAM is also supported. And if your drive is able to write Blu-rays, the recordable and the rewritable variant is both supported. So, and that's where the main work went in when creating this major update. Few other things that are notable. There is a new feature that I like very much because it is an alternative to CDFS. CDFS is my old enemy, is endless source of bugs and strange behavior. And the disk extractor is some kind of a filing system, but it is not a real filing system. So you have a filer-like UI. You can look at disks, you can look at disk images, but it is not a real filing system. So not a complete replacement, but a very good alternative. You can look at the content of every CD, of every DVD, of every Blu-ray that has an ISO 9660 image on it. Every drive I have tried works fine in the reading department, and you can also look at image files very easily. Also with the large CDVDBurn format. You might know that RISC OS has a limit of 2 GB per file, or the later incarnations of RISC OS 5.24, I think, can now handle 4 GB of data, but Blu-ray supports up to 100 GB per disk. So CDVDBurn had to invent a special format that is a directory that contains many files that are all 2 GB at size. And this image file, which is a directory in truth, is also directly supported by the disk extractor. So you can look at the content, you can extract files, you can extract directories. It is a very file-like UI, so quite easy to handle. The medium, the type of logical formats that are supported are the standard ISO 9660, and Joliet extensions are supported, and ROG-rich naming extensions, so you have no limitation with respect to a selection of characters in your file names. Everything just works. The most important thing about this disk extractor is probably to avoid all the CDFS annoyances. If you have ever seen the ambiguous disk name error just when you forgot to dismount a disk and accidentally put the same disk into a different drive, you can't exit this error in CDFS. You have to kill the whole filing system and re-init it. This is really, quite annoying. So the disk extractor solves this problem fine. There is also a minor new feature that allows you to verify a disk. So you can actually compare after the writing process that what was actually written onto the disk is the same as the source data file. There are a few small UI improvements that just hit me during new development. And I fixed them as I went along. It was also a good idea to just get my code base known better after all these years. I'll give you a bit of a history of CDVDBurn development, and you will see that there was quite a long time gap. And so it is always a good idea to also do the easy things if you start development again after such a long time. So there is also a lower price. So it is now cheaper than the original CDVDBurn was back in 1997. So hopefully that will motivate some of you to just buy the upgrade or the full version. So I'm going to run down through the audio features and the data features that are already known to those who know CDVDBurn and CDVDBurn. So for audio CD writing, there is an audio CD database. It is not FreeDB that some of you might know as the online database. It is an own implementation, so you can only have your own CDs in there. But nevertheless, if you're creating audio samplers, best of CDs, it is still nice to see which tracks you're actually handling. You can extract audio tracks in a WAV format. You can combine those extracted tracks to new collections, as I said, best of CDs or whatever you want to create. You can write it in both important writing modes, track it once, disk it once mode. This was often a problem in earlier versions, but the new drives that are officially supported are now both supporting those modes. The disk at once mode is good for real mastering of disks. You can set the pause between tracks to 0 seconds and don't have any clicks between the tracks. So this is most important for people who like to record, e.g. live CDs and still separate it into tracks. So CD Extra, not really well known, but it is a good possibility to put data and audio on one CD. It's basically a 2-session CD with the first session audio and the second session data. The computers know that they have to look at the second session, and the audio equipment just sees the first session. So this might interest one or maybe none of you. I think the data features are more important because they are not just working on CD, but also on DVD and the Blu-ray. ISO 9660 is the important standard for the data format. You can produce disks that are compliant to level 1 and to level 2. You have a very flexible character conversion feature built in, so you can optimize the output, e.g. for old CDFS versions. If you want to transfer your data to your RISC OS 3.1 machine, this is a good way to, without going through the zipping it all up, just to achieve the same file names that are on your source disk. Case preserving is possible for old patch CDFS. There are patches for CDFS available starting with RISC OS 3.1. And you can select a special character conversion mode in CDVDBurn that actually allows you to create those slightly non-compliant disks, but CDFS is happily reading them. And because you can add the Joliet extensions, all other systems, apart from DOS possibly, will also happily read those disks, because they are not looking at the ISO 9660 part, but at the Joliet extension part. So that this is slightly off standard will not ruin your cross-platform compatibility. Joliet extensions provide you with long file names with the full Icon Latin 1 character set. You have unlimited directory depth. There are some limits in ISO 9660, but this is usually not enforced by the filing system. But Joliet gives you official support, standards compliant support for unlimited directory depth. So CDFX extensions, very important, because this is where all the special metadata of your Icon filing system, RISC OS filing system is ending up. So the file type, the access rights, the timestamp, or even the load exec address pair is stored in these extensions. These are completely transparent to other operating systems, so the disk created is still cross-platform compatible, because the ISO standard was really made to have such extensions in a very clever way, and CDVDBurn 3 supports those CDFS extensions, of course. The user interface to create such a disk is standard drag and drop in a filer-like way. This is something I will show later in the live demo. There are also a few things to keep in mind, because there are some areas where problems may arise, and I want that everyone who considers to buy a CDVDBurn 3 to have those in their mind before they decide to actually buy the software. So the first important thing is speed. We all know that most RISC OS machines are not really good at fast I/O. We are still limited to USB 2.0, which is not the fastest one available. The speed is limited on the Raspberry Pi, which uses the micro SD card as its main storage. It is also limited. We are talking about, on a good day, perhaps 20 megabytes per second, perhaps a bit more. So RISC OS itself is also the speed limit, because USB 2.0 would go a bit faster in theory, but what you get in practice is around 20 megabytes per second. So CDVDBurn 3 tries to be clever with buffering and tries to multitask as well as possible. And the multitasking is just better if you slightly lower the writing speed. So if you're doing DVD writing at 8 times speed, it is usually okay on the Raspberry Pi. On the faster machines that have serial ATA with their main hard disk, you can go up to 16 times speed. But I wouldn't recommend much higher speed. So, and that brings us to a Blu-ray, which is where the data density is a lot higher. So the writing speed, the single speed writing speed is already at 4.5 megabytes per second. So if I told you 20 megabytes per second is a limit on USB, and you are reading from USB and writing to USB, this halves the available bandwidth. So you can only write with around 10 megabytes per second. So it should be easy to see that you are limited to probably double speed writing on a Raspberry Pi. So that is something to keep in your mind, because double speed means that a full Blu-ray with 25 gigabytes will take you 40 minutes to write. Another thing, drive compatibility. I put in a lot of work to get a maximum compatibility across a wide range of drives, but there are some drives that just don't behave well. I'm not sure where the problem is, if the problem is really the CDVDBurn part, or if the problem is the RISC OS part, or somewhere deep down in the USB stack, or maybe in those USB serial ATA converters. I've not tracked it down. All I can say is please look at the list of the supported drives and only use drives that I have tested and found okay. Media selection. Think twice before you buy media. Please use quality media. There are a lot of brands out there that provide good quality media. Stay away from the really cheap media. It is just not worth it. The medium, even the quality media is really cheap enough. It is not worth it going cheaper. Okay, so now I'm switching over to RPCMU. Hopefully this will work, and I'll show you what CDVDBurn 3 now looks like. Okay, I talked about UI improvements, or an important improvement is that actually the user is shown a result of the drive scan if it fails. So you see here in my emulation environment, there is no access to any reader or writer, and the CDVDBurn tells me that. And it also automatically selects if the USB drive changed its ID from startup to startup, and it automatically tracks this drive. So if you have only one drive connected to your computer, you just have to select the drive once and be done for all time. Okay, what I want to show you is the new disk extractor. This is here a menu option. So, okay, perhaps not world's best UI, but I think it is sufficient. I have 5 images here, no matter if they are strangely file typed like these 3. I go to full info so you can see how large they are, or if they are correctly file typed with the ISO image file type. No matter what, you just drag them to here, and the image is scanned. You see here in the title if it is an ISO 9660 format, or if Joliet extensions are detected, and then you can just navigate in the usual way the filer provides through the directory structure. It is really quite a close implementation that tracks all the filer features, like here, just click, close, and navigates up, and just double click replaces the window with the newly opened directory. And if you want to extract things, it's just selecting the things, dragging them. You see file action window. You even have the faster knob button that you all know from the filer. So it is quite close to the filer. So it is not a real file system. So you cannot just double click on an application and it will start. You have to extract it first. What works is e.g. text files. If you drag them to StrongAdd, these things work, but not the fancy stuff. Okay, so this was a plain ISO 9660 image. You can also have a look at something. Not sure if select, yes, RISC OS Select 1. The older ones remember good old times. So this was mastered with Joliet extensions, and you can see it here. It is actually mixed case characters, even with space in between for the file names. So you can also see when I'm clicking, it is quite fast and navigating through the image, despite being really quite large images. So there is not really a performance problem here. Everything works nice and fine. Another thing I wanted to show you is the creation of such an image, because this is the same file-like layout. This is the ISO 9660 naming stuff that I mentioned earlier, where you can select really the plain ISO level 1, maximizing the compatibility, or you can say, okay, my target is Icon CDFS. Just remember the Add Joliet Extensions button, option button, so that you are creating standard conformant disks. And then you just say open ISO filer, and this is the root of your image you are creating. And then you're just dragging and dropping stuff from the filer window to your ISO filer. Just click on generate image. And then it will create your image. And now with the new extractor, we can directly look at what we have created here. Okay. So that was the demo effect. You will just forget what you saw, and we'll restart. Serves me right not to try out the demo path before. So now it works properly. This is exactly the correct layout we have created before. And you can now just extract. You see 140 megabytes just extracted in a few seconds. So the extractor is really quite speedy. Okay, so I cannot show you in this emulated environment what real disk writing looks like, but it's really completely unspectacular, because you just see the progress indicator going up from 0 to 100%, and then I could pretend that, hey, I've written the disk. So this does not make really a good demo. Okay, so back to the presentation. So after that, don't know if you really want to buy this software that crashes while its creator shows it to you. But anyway, I'm going through the how to buy tutorial. So it is online ordering, it is digital delivery, you get it by email. You just go to the Huberson software website and click on the buy button, and then you can pay via PayPal or get the details of the banking account. And the pricing, as promised, is a bit cheaper than the original CDVDBurn pricing, so 50 pounds or 60 euros, whichever suits you better. For the full version, for an upgrade from CDVDBurn, it is half the price, and as a special long-term loyalty user option, there is also upgrade possibility a bit cheaper from CDVDBurn, where it is £40 or 48 euro. No price reduced upgrade from CDVDBurn Lite. You might remember the Ionics was bundled with CDVDBurn Lite, and there was a cheap upgrade option from to the original CDVDBurn, but no longer available. Okay, so software is never finished. Obviously, I have an important bug to fix that we found out previously, but there are a few other things that might happen in the future, depending on what the customers really want. So do not hesitate, send me an email, tell me what is an important feature for you that you would like to see in CDVDBurn 3. So here are my suggestions. The most important thing to me is that we get the USB 3 working on the Raspberry Pi 4. That should give us a nice speed boost. Not only when writing DVDs or Blu-rays, but also when reading from the source disk, which is as important for the overall performance. One thing that would always be nice is just to support more drives. I know that many of you have USB drives at home you're using with your PC or with your Mac. And of course, it would be nice to support all of them. But this is also the most time-consuming thing to implement. So if someone has a drive that is not on the official list, just mail me and we'll sort the test version out so you can test drive your drive. This is one I probably will do anyway, adding back the stuff that was in CDVDBurn, the predecessor version for the RISC PC IDE, several IDE modules and SCSI modules support. This should be not too much effort to actually do. The problem is more that this starts another round of testing, looking which drives are actually supported. You know, the RISC PC IDE is a bit picky with respect to drives. Not sure if this is worth the effort, because the testing effort that follows from adding back the code is quite extensive. 3DB, I mentioned it before, audio CD database. This is also not too complicated. Hopefully there is already a module for RISC OS that supports the basic things, so that should be easily done. But previously, most customers told me that they are not really into these audio features and that they are more interested in new features for data CDs and DVDs and Blu-rays. So not sure if this is worth it. Another thing that might be interesting, more audio source formats so that you can just drop your MP3 to use as an audio track. This might be possible to easily implement with the disk sample module that is also used by digital CD. So I'm looking into that. Then when extracting the audio tracks, your only option at the moment is wave format, which is uncompressed original audio data stream, which is a good thing. But sometimes it would be a good idea to just create MP3s directly to play back on your MP3 player. So this is something that might get done. Something more esoteric. The Unix guys invented the Rockridge extensions to work around the limits of the ISO 9660 format, and this is interesting for supporting older versions of various operating systems. So it might be a good thing to strengthen the data transfer thing to old machines. But this is comparatively little effort, but I'm not sure if it is really worth it. How many people would be interested in that? No idea. UDF support for the disk extractor. You might know UDF is the successor for ISO 9660, a lot more complicated format, but used in various forms on video DVDs and video Blu-rays. So to get to the content of unencrypted DVDs and Blu-rays, this might be a good idea. So we just need the playback software for these discs. Another thing, as I said, one of the main use cases I see for the optical discs is archiving and backup. And it is always a good idea to have a possibility to check the actual quality of your archive as it gets older and older. And CDs and DVDs and Blu-rays have several things that help them to keep data integrity. And you can actually get at the data that the drive creates to automatically correct the errors that creep into the data. It's the whole data, not the data that you actually extract. There is quite a bit of redundancy inside the data, so you can automatically correct errors. The drive does this automatically for you, and you can scan for those errors. It is, there are two levels of error correction called C1 and C2, and most drives nowadays give this data via a special API to interested software, and this could be used to do something like a quality scan feature to just check your old disks if they are still in good shape or if you need to copy the data away. Okay, so that was the promotion part. Are there any questions you would like to ask for this first part? Trying to look at the chat.
I have one question actually. You were talking about the speeds on USB. With the ARM-X6, is the drive USB connected internally, or is it on SATA? Or I don't actually know, even though I've got
USB connected. The WAN port that is the basis for the ARM-X6 only has one serial ATA port, and obviously the hard disk is connected to that fast thing. And the optical drive is always connected via an adapter. So it's USB, actually.
Okay, so it's got the same limits as the Pi, basically, of throughput.
No, because the source is much faster.
Oh, yeah, of course. Yeah, so
the source drive is much faster, so you can reach much higher speeds, but it is not as fast as the titanium.
Yeah, okay. David's got a question in the chat. Can we rip mixed CDs of audio and data the working ISO?
Interesting. I think that Jonathan Abbott has done some extensions for Fake CD Faker, that soft loadable driver for CDFS that can mount images as CDs. And I think this should work out. I'm not sure if CDVDBurn can produce the right format. I would have to discuss this with Jonathan. Okay, another question related to USB 3 and if CDVDBurn 3 will be able to just use it directly and directly benefit from it. The answer, I hope, is yes, because the API from the standpoint of the drive should be the same. So it should automatically profit from the speed, and the compatibility should remain the same. Okay, another question: is the Extractor's file-like display as flexible as filers? Yes, with one restriction. There is no alt rename feature, so you cannot alt click on the file name and rename it directly. I think that everything else, so you can have large files and small files and full info and different sorting orders. So it is quite the same as Filer, but Filer at RISC OS 3.7 feature level. Okay, another question from Robert. Is CDVDBurn still written in ADA? I will come back to that later in my presentation. As I said, now should start the interesting part, and this is one of the most interesting things, I think. Another question about, oh yes, drive compatibility. The Samsung drive, the SH224, this is my nemesis of drives. It will not work. I cannot get it to work. I have no idea why. There are any kind of strange timeouts. It is also not an ARMX6 problem. It is, you can see it on the Titanium, you can see it on a Raspberry Pi with any USB S-ATA converter I've used. I just can't get it to work. I have 3 drives here that work fine on the PC, but not with CDVDBurn. Sorry for that. Still working on it, but I have very little hope. So now starts the interesting part. A bit of history. It is quite interesting how CDVDBurn, the first version, was born as a product. Start of development was in 1997. I had actually a SCSI CD writer since 1996, but used it with my PC and not with my RISC PC. And then I literally stumbled over some command set API description for exactly the CD writer I had, the Philips. And I did a bit of prototyping in BASIC, and I had never before used the SCSI API to do anything. And this turned out to work very well. The documentation by Philips was really first class. And so it was really kind of luck that I actually bought the drive, the only drive that had the command set publicly documented. All other drive manufacturers had very strange ideas on what hoops you had to jump through to actually get at this command set documentation. I remember I had to send a fax to Yamaha in the US, and months later I got a letter, and they said, no, they are not interested to give me access to the command set documentation. Very strange. And many other companies were just the same. Sony would not talk to you unless you promised to sell millions of your software. And TIAC was also very difficult to deal with. So it was Philips and OEM drives, and this was the start of the whole story. RISC PCs, SCSI drives, PowerTechs, SCSI Podule. And the first prototype was already able to write one data track and several audio tracks. It worked in simulation mode, and then I just removed the simulation bit, and it wrote its first CD. Not one coaster written, so the documentation was really first class. Back then, there was already one CD writing software, also for the Philips drive. It was by ESOX, who did many of the soft loadable drivers for CDFS. It was a CD Scribe. It was available for a really high price. The drive alone cost me 800 Deutsche Mark back then, and they wanted for the bundle nearly double that amount. And so I already had the drive. I just needed a software, but it looked a bit too expensive. It did basically the same that my prototype in BASIC also did. So there was, when I followed the RISC BSD, you might remember the NetBSD port for the RISC PC that was in development back then. And on the mailing list, someone asked, I need to write a CD. I have no software for RISC OS, and is there something on RISC BSD that might help me here? And there were back then big problems with I/O speed in RISC BSD. So the answer was, well, no, it is just too slow. And then I wrote to the mailing list that, oh, well, I have that basic prototype that might actually work depending on the drive. And a few days later, I received an email from Robin Watts. You might remember him from Warm Silence Software, that they would really like to make a commercial product out of that. So, well, this was July 1997, and or was it already August? I don't remember precisely, but Acorn World 1997 was the target release date. So, yeah. I had to do some development because, as it turned out, if you want to create an image for the ISO standard, you really want to have proper data types. You want to have proper data structures. You want to have record structures. You want to handle things in a high-level way. And this would have been very difficult to create in BASIC. So I had to consider the options, which programming language I was going to use. I didn't have the DDE, the C compiler back then, because I was a very poor student. I just bought the CD writer, so there was not much money left. So I looked at the languages I learned up to then. So I had experience in Locomotive Basic. Some will remember the Amstrad CPC. That was my first computer where I started programming. And I also knew S-ATA assembler, so not much use on a RISC OS machine. I also knew Turbo Pascal, no sensible Pascal implementation on RISC OS available. I knew BBC Basic, and I knew it was not what I wanted to use to create an ISO formatter. I knew ARM assembler, so that would have been even more complicated. At university, I started with Modular 2, one of the VIRT languages. no compiler available for RISC OS. Then a new Lisp, nothing available for RISC OS. A new HP precision architecture RISC assembler, obviously completely useless on RISC OS. And I knew ADA. Two styles, ADA 83 and ADA 95. And there happened to be a compiler based on GCC available, the GNU ADA translator. So that was the one. Icon World 1997, end of October was the release date. As I said, I started around August 1997, so hurry up. Robin just said one thing that was important for warm silent software. The software must fit on an 800 kilobyte floppy disk, because that's how they distributed all their software. So that was the most important thing. So time is in short supply. The ADA compiler was available, and after a few quick tests seemed to be capable. So thank you, Peter Burwood, wherever you are now. This was a great compiler port. I'm still using it today. The only open question was, can I easily call software interrupts? And yes, it worked. So I'm going to write CDVDBurn in ADA 95. The first version, the one that was actually sold on Icon World, was basically a straight port from the BBC Basic, including all the WIMP stuff. It was a very thin veneer on all the WIMP SVIs. So we called it 0.99 because it was not really ready, because the ISO formatter was still missing. And so we released a product that was useful, but that was not complete at Icon World 1997. We just needed something that was able to create ISO images. And so Peter Burwood to the rescue again. He created a quick port of isoform, one of the Unix based utilities to create ISO images. And well, that combination did enough to make quite for a few successful sales at the show. So now the rest of the history of CDVDBurn and CDVDBurn. In 1997, shortly after the show, I actually had the ISO formatter working. So everything that follows now, new features were always free for existing customers up to CDVDBurn. In 1998, the rewriters started to appear, and the MMC standard, so it became a bit less problematic to actually get the command set documentation for the drives. It was just then the new challenge of interpreting the standard in creative ways so that the drives actually worked. Multi-session was added as a feature, and Joliet extensions were supported because warm silent software had a CD-ROM FS available, which was able to read the Joliet extensions. So that was a nice combination of products from warm silent software. In 1999, it looked very much like IDE drives will take over the world. Less and less SCSI drives appeared and were a lot more expensive. So most people were interested in the cheaper writers with the IDE interface. So the RISC PC IDE was supported in 1999. In 2000, the third-party IDE modules from Simtech and from APDL were supported. In SCSI world, everything used the same API, but unfortunately in IDE world, Aircon did not set a proper standard, so I had to implement all IDE modules in a different way. In 2002 was something like a miracle, because 32-bitting was the problem. Castle approached me. They wanted to bundle CDVDBurn with their Ionix PC, and they needed a 32-bit version. And well, the ADA compiler could not create 32-bit executables. It had an ARM backend because it was based on GCC 272 that could create 32-bit ARM code, but the whole runtime was 26-bit. So the part that Peter Burwood actually ported was 26-bit, and the source was not available. So you need an expert. You need an expert to help you. You need someone who is able to convert code from 26 bits to 32 bits. We know that Martin Würtner is the guy to do that, because he did that for Artworks, and anyone who can do it for Artworks can do it possibly for everything. And you need someone who knows how ADA works, and GNU ADA compiler. And again, Martin Würtner was the guy who knew from university much more about ADA than I will ever know. And it took him 2 days, and I had a working 32-bit runtime for the ADA compiler. And therefore, I wouldn't be here today to tell you about CDVDBurn 3 if it wasn't for Martin's excellent work on my development environment. So thanks again. In 2003, there was the first proper version, 32-bit CDVDBurn. The CDVDBurn Lite for Ionix bundling was finished. Ionix IDE needed to be supported, because it was yet another way to handle IDE and ATAPI commands. So 2004 saw me founding my company that I still have now, Huberson Software. Warm Silent Software started to go elsewhere. You might know that Robin Watts is now with the company that does GhostScript. So they were no longer really close to the RISC OS market. So I thought it would be a good idea to take back the CDVDBurn rights and sell it on my own. 2005, Wakefield Show saw the release of CDVDBurn. This was the first time that it was actually a chargeable upgrade. It added DVD support, but it lacked a bit in the drive compatibility department, and there was endless problems with CDFS compatibility for drives. So it was not really a very good, stable release of CDVDBurn. It really only worked well if you had that one specific drive that was supported. 2006 was version 2.02. It was a public beta version that added the DVD RAM support. And it was the last one for a really, really long while. So 2007, I started implementing the CD and DVD extractor. No Blu-ray support up until now, but bit later, I got my first Blu-ray drive, and Blu-ray recordable and rewritable discs turned out to be quite easy to be supported, but it was difficult to achieve the necessary speed for even single speed writing back then on the Ionics, because the Ionics IDE was fast for hard drives because it could support the UDMA transfer modes, but for optical drives it was still PO mode 0, which is not really fast. 2010, I got the BeagleBoard and the newly ported RISC OS 5 and started experimenting with the USB, and not much worked, but I tried to help Jeffrey Lee as best as I could with this low-level stuff, and at least a working CDFS soft SCSI driver for USB CD drives came from these long debugging sessions. Then another long pause. As I said, still no public release of any new version. I added support for titanium serial ATA, and the Raspberry Pi 3 came around, and it turned out that the ARM v8 architecture was quite a bit different to ARM v7, and CDVDBurn did not even start up. So I had to binary patch the runtime to be ARM v8 compatible. Yeah, something I hope I will never have to do again. So that brings us to 2020. In December last year, actually CDVDBurn 3, the version I presented to you previously, was released. So 16 years between the last public version and a new release. So why? Just want to explain a few of the reasons why it took me so long. Endless frustration with drive compatibility. Really, I have a big stack of drives, probably more than 50 IDE and serial ATA drives, and additionally a lot of SCSI and USB drives. I guess in some probably 80 or 90 drives, and all behave slightly different. One of the problems was that USB in RISC OS 5 worked very well for USB sticks and hard disks, but not for optical drives. But it got better all the time. IDE on the Ionics was just too slow. It was just not possible to write something like Blu-rays or even DVDs with a speed that was good enough that I considered to be sensible to actually sell software for. The power supply was an endless stream of frustration. Back then, the RISC PC was still the most used hardware by my customers, and the power supply was just not good enough. A lot of the modern drives take 2.5 amperes at 12 volt, and this is already more than the weaker of the two power supplies in the RISC PC could even supply. And if you add a hard disk to it, even a stronger power supply was not good enough. So it was very difficult to find a drive that would actually run with a RISC PC power supply. And then the next problem, a stroke, which was a CDFS compatibility problem. CDFS soft ATA was really not good enough for most drives. Another thing, one of the formats where the media is of the highest quality and of the lowest cost, I couldn't get it to work. I tried really long with many variants of commands thrown at the drive and couldn't get it to work in the -R format. The GNU ADA compiler exhibited several problems when producing 32-bit code. I had to recode some of the things. I had to remove cool features from ADA to go more bare bones inside the code. And this is something a software developer just does not like. And fighting the compiler that it produces legal binaries is not fun. And the GNU runtime that it was not compatible with Raspberry Pi 3 and later was another thing that yeah, led to a bit frustration. It was solved in the end, so you could say everything turned out fine in the end, but as I said, 14 years. It took me 14 years. So I told you already quite a bit about ADA, and I'll expand on that a bit. So ADA is one of the most exotic languages you encounter nowadays. It is seldomly used in industry. It is usually one of the military languages, as they say, because it was once upon a time mandated by the Department of Defense in the US. So every US company that did military equipment wrote their software in ADA, but not many more people did so, which is a shame because it is really a very nice language. It is a multi-paradigm language. It started out in 1980 as a procedural language, but they added really nice object-oriented features, a very clean extension to add inheritance to the language. And they say that the first incarnation of ADA was actually object-based, not really object-oriented. And ADA 95 that I used for CDVDBurn is a true object-oriented language. You have strong typing, you have a very rich type system, you have so many different types, a clever way to define enumerations, you have different numerical types that are cleanly separated so that you don't accidentally mix up your types. You can even have the same base type being made incompatible with other with the same other base type. It is really very expressive to use the type system. Really very nice. Good support for modularity. You have fine-grained visibility, very nice rules about visibility, really powerful to help structure your software in a way that it makes it very hard to shoot yourself into your foot. Tasking is another thing. Really, amongst the languages back in the 90s, it is by far the best abstraction for concurrency. Well, it turned out that tasking was not supported in the RISC OS GNU ADA compiler, which is a bit of a shame. But if you ever encounter ADA in on another operating system, tasking is really cool for concurrency. If you define records in other languages, you always have to use the correct types to actually fit what you want to see as a layout in memory. In ADA, you have representation clauses where you can define the record layout down to the last bit. Really nice feature and helped a lot in CDBurn and CDVDBurn, where you have to send commands on a bit byte word big endian, little endian, everything you could imagine. And ADA gives you a very good abstraction there and a very good definability of the records and the memory layout. The compiler catches many errors, so development in ADA is very speedy because you do more coding and less debugging, and the compiler takes care that everything will turn out right. Everything that the compiler doesn't catch, the runtime checking will catch, though there is absolutely no way to get a buffer overflow or something like that in ADA. The runtime will check that unless you tell the runtime, don't check this. You always have the power in ADA to overwrite everything, but you have to make sure that you want exactly that. So unsafe is always possible, but you always have to choose explicitly that you want the behavior to be unsafe. For 1995, ADA is very advanced in the string department, Unicode 2 bytes, 4 bytes representation, what is now known as UCS2 and UCS4 is supported in the standard library. You have many features, exceptions, generics, you have operator overloading, everything that was fancy in the 1990s. ADA already had it. What is quite nice is that it provides a way to achieve low-level to high-level interoperability. So you can code in a very high-level way, and where you need, e.g. calling a RISC OS software interrupts, or whatever API, e.g. a C library will provide, you can still convert your high-level stuff really easily to the low-level nitty-gritty details. So, ADA, really nice language. Now on to ADA on RISC OS. So don't use it. This is my official recommendation. Using a compiler of a 1995 vintage to produce code for machines in 2021 is not a good idea. I mean this, don't use it. Or maybe you could use it, but only if you know exactly what works. You cannot expect to pick up any ADA book and read about all the good stuff in the language and then write some code and expect that it works on RISC OS with this GNU ADA compiler, this old version. Chances are it won't. As I said, it is based on GCC 2.7.2, but astonishingly, it can produce valid ARM V8 code, but yeah, it's a struggle. The compiler is slow, it is memory hungry. Nowadays, it is no problem because I have a virtual environment. I can just tell RPC EMU that it should use 256 megabytes of memory, and that is more than enough. But back then, with my real RISC PC, with 8 megabytes at the start, it was impossible to compile anything. So starting with 32 megabytes, if you kept your classes small, it worked most of the time. Okay, the only good thing that is really a recommendation for using ADA on RISC OS instead of C is you don't need make files. You just say not make. This is a command to automatically detect the dependencies and compile everything. And you just tell it that this is your main source file, and it just compiles whatever has changed automatically. This is really nice. So my make file is just an obey file that does not make run image, and everything works automatically. As I said before, Emular is not a solution, unfortunately. It doesn't run, the compiler doesn't run stable on Emula, so only 26-bit systems are really usable. RPC-EMU is my emulator of choice with RISC OS 4. This works quite nice. So, what next? I told you about few feature plans I have for CDVDBurn, and some of them will probably happen in the near future, but it should be clear that this is, I won't say it is a dead end, but I don't think that there will be a new optical disc format after the current Blu-ray XL, which supports up to 128 gigabytes of capacity. But I don't think there will be a successor. New drives arrive much less frequently. It is mainly evolution now. No new features in drives in the last, say, 5 years. I think the M-Disk was the last innovation that was really done for the drives. So not much progress there. And of course, the use cases are difficult to find. I told you about 3 of them at the beginning of the presentation. They don't get more. So USB sticks, SD cards get cheaper and larger every year, and the use case for optical discs will just vanish even more. As I said, I have many drives that I have tested in my life, and it is time consuming. It is expensive to buy all those drives, and it is not really much fun to test this, because it is, if you want to write a full Blu-ray, you need a lot of storage, and you need to have a lot of patience until it runs through, and you need to inspect the log if anything happened during the write. Is really a lot of work. It is time consuming, and not something I want to do much in the future anymore. So what comes next? So I thought about these things, and one of the things I miss when I develop on RISC OS is the development tools I have available on other platforms with other languages. Do I really want to continue with the old ADA compiler with StrongAd as my integrated development environment? Do I really want to fight with hardware like optical drives again, or is this really a good idea? Maybe there's a need for cross-platform tools. Maybe there are more people like me who are using RISC OS on native platforms as well as in an emulated environment. So maybe there's something to be done there, and maybe even emulator-specific tools. And my day job consists of Java programming. I do graphical interfaces in Java Swing, and some other large application stuff for big insurances, where our product is very, very successful. And this is what I do, what I did for the last 20 years, and I'm still doing. And the development tools are just so much more powerful than what we have on RISC OS. So a new idea was born about a future product. The idea is to write the software in Java. So write the user interface in Java Swing, And again, start to write software for my own needs, and then hope that my needs are possibly matching the needs of others and are not too esoteric and too exotic. The plan is to write software for RISC OS, but not software that runs on RISC OS. Well, unless someone starts to port a Java environment, of course, which is possible, but yeah, a lot of work. So I'm now showing you 4 pieces of software that I have created in the last few years and that are nearing completion or are actually building blocks for the final thing I will show you today. Okay, so the demo, hopefully that works out. The first thing I will show you did it open somewhere? Nope. So this is called Archive Reader. It is partly based on software by James Woodcock called RISC OS Arc, which is a Java library that handles ARC files, Spark files, PACDL files, so everything that is LZW compressed. And I added the possibility to interpret the zip extensions that SparkFS introduced. And so you can just say one CDVDBurn archive as I send it out by email. And then you see the structure of the file of the archive here in this tree view. And you can also take one of the files and drag it out. Well, it should be possible. Negative time. So you see automatically the comma separated file type is added here, ready to be used in the emulator of your choice. So hostfs compatible. The archive reader, as I said, is able to show you the content of zip archives and also of ARC or Spark archives. You can see here the content of any old ARC file, I think downloaded from Arcade BBS possibly. So that was one of the Java UIs I quickly created. And as I said, nothing big, but a building block for things to come. So demo number 2 is actually a command line tool. It is a BBC Basic detokenizer. And this is a Java code I wrote because I just wanted to know how the BBC Basic tokenization actually worked, and implemented a Java decoder for it. So you can use any BBC Basic source code. I took one from my basic prototype of CDVDBurn, and then detokenize it with this Java code, and it just prints out on system out the detokenized version of this basic code. So this turned out to work really well. So I went on to another of the native RISC OS formats, sprites. I created an application called Sprite Viewer, which is able to open sprite files This is the sprites 22, all the file types that is found in, I think from RISC OS 4, if I remember correctly. So you see, I've implemented, again, Java-based. I've implemented a sprite decoder that is able to convert any sprite file, no matter what bit depth, no matter if it is RGB ordering or BGR ordering, or if it is 15-bit depth or 24-bit depth, if it is alpha mask or whatever, it converts it into a Java image icon, and you can export it in any format you like via the Java standard library. And you can also double click on it and zoom it a bit. This is more a demonstration than a useful feature. But anyway, so I had a Java library that could handle sprite files. So what do you do if you have an archive reader, a BBC Basic tokenizer, and a sprite decoder? Okay, so this is the thing where it all comes together. And it's called FileCore Image Reader. It is, again, implemented in Java, and it can interpret FileCore images, the one you usually use in emulators, Arculator, RPC-EMO, Virtual RISC PC, ArcM, RG-EMO, everything works on FileCore images. And okay, the first is very unspectacular, blank disk in E format. You can see the details of the format that is detected for the FileCore experts. You see here the properties from the format. It can currently support E format and of course F format disks. The FileCore experts see that, of course, the F format disk has 4 zones. And it can also, of course, open larger hard disks HDF format, which is also, of course, FileCore. There it will take a bit longer, because I think it is 512 megabytes, if I remember correctly. So now you can navigate through the directory tree on the left-hand side. And on the right-hand side, if you select the directory, you see a filer-like display. Another filer I have re-implemented. You see when resizing, it dynamically resizes the same way that the RISC OS filer actually does. And if you have something like e.g. text files, you can double click on them, and they open here in the content view. And then you have the basic detokenizer from demo number 2. And of course, I built that into that too. So you double click on a basic file and it automatically shows you the content. Then there are files like OPA files where you can just visualize the text. And if you have modules or utilities or something like that, it currently resorts to a hexdump view. If you have sprites, just double click on them, and the code I've shown you previously of the sprite viewer is reused here. And so you can browse that whole directory structure and look actually at the content of the FileCore image without resorting to firing up your emulator. So you can use the whole CPU power of your PC or your Mac, or your Linux machine. Windows works on everything because it is Java. Write once, run anywhere. Big disks are not yet supported. There are a few weaknesses. Deformat is currently not working for old style floppies, but I'm working on that. In principle, old directories are supported, old maps are supported. So nearly everything you could possibly wish from a FileCore image reader. So, some technical details about the implementation. It is a cleanroom Java implementation, so no previous code used. I know that there is a disk image, which is written in Delphi from Gerald Holdsworth, and there is RDFS lib in Python by David Boddy, and there is the ADFS module for Linux. But yeah, C code, I won't touch that. So cleanroom Java implementation based on PRMs and actual example files. I made it compatible down to Java 7 so that it is no problem to execute it on Windows versions as old as Windows XP. This was my main target because it is a companion for emulators and it is a companion for machines that are still able to image floppy disks. And it is always a good idea to check that image that you just imaged from a real floppy. And so FileCore Image Reader should be able to run on the same machine that you imaged the floppy. So Windows XP is probably the last operating system where it was easy enough to drive floppies directly to actually be able to image ADFS floppies. Latest Java, no problem. Java 16 runs as well as Java 7. Cross-platform, you can run it on Windows, on Linux, on Mac OS. The content view handler you saw that showed the basic, the text, the sprites, the archives, whatever, is pluggable, so you can provide your own content view handler. The Swing UI is created in a way that is look and feel neutral, so you can use whatever you find fitting, Nimbus look and feel, whatever. It has full internationalization and localization support. What I've shown was user language English and country Great Britain. So I also have a German version for that, of course. So when will it be released? Once I've properly integrated the archive reader. Thanks again to James Woodcock for RISC OS ARC MIT licensed, really nice library to support all the old archive formats that were born on RISC OS. It even supports CFS, if someone remembers that compressed filing system by Computer Concepts. And PacDear by John Kortink is also supported. So very nice overall solution. Big disk support is not ready yet. I'm working on it. There were several filing systems that supported partitioning schemes. Every SCSI Podule and IDE third-party Podule supported some kind of partitioning schemes. And the Witzo IDE stuff for the A5000 fifth column ROM supported partitioning. And there were also eADFS by Gary Partis. And this is already on the way. I have example images for eADFS. This will be supported shortly. Few known bugs, deformat once worked, no longer worked. I have to look into my Git history. where that went wrong. There are some problems when images are not as expected, like zone checksums or directory checksums are failing. This is not properly reported to the user at the moment. And I have to decide on the feature set. The plan is to provide 2 editions, a free edition that allows you to just look at the content and extract single files, and a pro edition that provides all the file icons, sprite viewer, basic detokenizer stuff. And I have to decide on the feature set. And the price, of course. The free will be free. That's already decided, but the pro, no idea. So once you start with software like that, you generate a lot of ideas. One of the ideas is to follow the idea of making data transfer easier. So it would be nice to just take one large image and create an ISO image from it to transfer it to a different RISC OS computer. I already have Java code to create ISO image with CDFS extensions, so that should be possible in quite a short time frame. zip creation would be cool because zip archives often are easy to transfer via floppy. And I'll leave the file types intact. So this would be a good idea to be able to create zip archives from arbitrary content of this FICO image. Yeah, more content views, of course, templates. Why not? Draw files, artworks files, maybe a disassembler instead of just showing a hex dump. So difficult to say where the sensible things stop and where the madness starts. So it is a pluggable architecture, so everyone can provide a viewer for their favorite file type. One idea is to extend it as a real RISC OS hostfs browser. Why base it on a FICO image? It is also often nice to be able to browse a hostfs directory structure as it would be shown from a RISC OS thing without starting the emulator. Natively opening known file types like a PDF, video formats, audio formats, graphics, whatever. That would be really cool. So you don't need to extract them before you can actually use them on the Windows side or the Linux side. One thing for the text files that is not properly implemented at the moment, it is using Windows 1252 code pages at the moment and not the only true Acorn Latin code pages. So this is something I need to implement for Java. Yeah, now we are going into insane mode. RISC OS look and feel would be nice. The Java Swing supports pluggable look and feels, and it would be possible to provide a look and feel that make a Swing application actually look very much like RISC OS. Not sure if that finds many interested people, but it would be cool. Another insane idea is to execute the obey file content whenever you open a directory, to actually boot the boot file, to just do the correct thing with the icon sprites. What I've shown you before was the code simply looking for the sprites file and hard-coded doing that, adding that to the sprite pool, but not actually looking at the content of the boot files. So that would be cool to simulate the RISC OS behavior better. So, and now we are getting to the point where I may again touch hardware. direct disk access, direct device access. It would be really cool to just take a USB stick from your Raspberry Pi and just plug it into your Windows machine and just open FileCore Image Reader and just read from it like it would be a native disk. That would be really cool, but not too easy from Java. I have already looked into that, but yes, it needs some native code. So that brings us to the end. I guess it was long enough. So any questions? Any comments? I'll have a look at the chat.
I'll just start by saying thank you very much, Steffen. That was really good.
Yeah, I hope it was not too long and too boring. So I got quite a bit into the details. So
I'll just stop your sharing and while I'm opening up for other people's questions. I have to say, I like the look of the FileCore Image Reader. I'm always thinking you could almost turn it into a decent file manager in general.
Yes, having something like a filer for Windows would sometimes be a really good thing. Yes, possible, but not my first target for a ready-made product. Okay, one question from David. Will you provide pre-compiled versions for Windows? Yes, that touches on the problem how to distribute your Java software. I have experimented with Exe wrappers and distributing the Java runtime in the same package, though this will happen. The new license conditions on newer Java versions make this easily done. The only thing that is not so nice is that the package gets quite large because the Java runtime on its own is already a bit more than 30 megabytes, but nowadays not the biggest problem. Those who want to save the megabytes can just download the jar and execute them in their own Java runtime environment if they already have one. Okay, one other question. No ADA for your next RISC OS app. Yeah, well, I think I would use C++. I think of all the languages that are currently available on RISC OS, C++ is the one that is in spirit the closest to Java, and Java is what I am used to be, what I'm used to, and nothing beats coding routine. So whatever language you're used to, you should use that. You should not use a language just because it is cool or someone else tells you that this is the best language in the world. Just stick to what you know and what works for you. And for me, it would probably be C++.
When you were talking about using higher quality media for the DVDs and Blu-rays, are there particular ones that you recommend? Because
yeah, I have very good experience with Verbatim and TDK. You just have to be careful because they usually sell two quality grades. Often the supermarkets have the cheaper ones, and you only get the high quality ones if you shop online. With Verbatim, you have to look that the branding is Data Life Plus and not only Data Life. The good quality media is the Data Life Plus. It is only slightly more expensive, but it is definitely worth it. Okay, another question. How easy was it to write Java code to handle all the different sprite formats? Oh, well, The most difficult thing was to actually find the documentation for all the different sprite formats. The later formats are documented on the RISC OS Open Wiki, and some sprite formats are on the RISC OS Limited, extended PRMs, and the old formats are, of course, described in the old paper-based programmers reference manuals. And the biggest problem was actually to convince Java to support unsigned types. Java as a language has not a very good typing system, a type system, and the available numerical types are all signed types. And RISC OS sprite format, as well as the FileCore format, just need support for unsigned types. So I had to roll my own routines to handle those, because astonishingly no one else did it, which is quite a surprise in the Java universe, because normally for everything there is already a library. But for that, I had to do my own. Okay, another question about the larger 120 gigabytes Blu-ray discs. Yes, you will be able to write it. I have tried the double layer 50 gigabyte variant and the XL, the smaller 3-layer XL variant that goes up to 100 gigabytes. This works, but of course you need a lot of patience, because as I said, the transfer rates are not that great, and the multi-layer Blu-rays are often only double speed. So writing 25 gigabytes double speed takes 40 minutes. So writing 100 gigabytes at double speed will take 40 minutes by 4. So yes, quite a while. Thank God I added multitasking, so it doesn't lock the machine for that time.
When you said you think optical media is kind of coming to an end, what is a good media for long-term storage of things now?
I have no idea. Possibly the cloud. I don't know. I live on the wrong side of a quite slow internet connection, so I have a upstream that is 5 megabit per second. If you try to upload, say, a terabyte of data, this takes quite a while. So I'm not yet sold on the idea of storing my stuff in the cloud. I think the most important thing to remember about digital archiving is to keep looking at your archive and just copy it to the next medium that comes along. I think that is the secret. I don't think we have that much data that needs to be read by generations and the next few generations. I'm not sure that I've ever produced any data that anybody will like to read 100 years from now on. So not sure if I'm the right one to be asked for long-term storage, really. Yeah.
I'd say tongue-in-cheek, store it on a RISC PC. My wife's been running hers since 1995, every day. Same disk. Bound to go wrong tomorrow.
Yeah. Knock on wood.
It is backed up every day.
It does make you wonder, though, when you think people get family photos from 100 odd years ago that they can look at. Yet nowadays people take way more photos, but in 10 years' time they might not be able to read them.
Yeah, I think I'm happy with photos because I've got them on DVDs, CDs, USB sticks, hard drives. I just copy them everywhere, and some in the cloud as well. So it's just, there's some safety in numbers there, and they're all JPEGs, nothing clever.
Parchment has lasted 1,000 years.
Yeah, well, if you're going pen and ink, you might as well go back to cave paintings. 300,000 years.
Yes, I think families are going to lose a lot of the history of because a lot of photographs, we take photographs willy-nilly now with our phones and things like that, and the history is going to disappear when that device is finished with. Whereas the old-fashioned photograph is still kept.
I noticed a couple more questions have popped up in the chat.
Yeah.
The
I'm
MDisc
trying to work out what DB means.
Sorry, upside down, Blu-ray. I'm typing on two different things at the same time, so apologies for that. Yeah, the new one that I forgot name, they can store like 50 gigabytes or something.
Yes, they are the dual layer things. So up to quad layer, everything is supported because from a software side of view, they are just a long disk, so you don't have to invoke any magic to do the layer jump stuff. In DVD world, it was a bit different. The -R format, the dual layer, had to be supported especially by the software. But thank God that died out very quickly, and the only dual layer and now available is the DVD+R format, and that is also one long media, so this is automatically supported. But actually, I'm not sure if I'm completely sold on the data integrity of multi-layered disks, because as soon as you have scratches on the surface, you have double the risk to lose your data. So
Right, yeah.
use single layer, it's safer.
Thanks. Also, one of the things that sometimes I've noticed that when I try to create very, very large archives on RISC OS, it's not always stable. I still have to try with 528, but older version sometimes with, I don't know, zip archives or other forms of archive, when they start to get very big, it can go wrong, unless it's something that you do just, the startup RISC OS, and you do it at that point, nothing else has been loaded. So what about the stability that you have tested of this software when creating very large images?
No problem really encountered. The only thing that usually makes problems is if you have a weak power supply. The Raspberry Pis are very, very very vulnerable to lack of enough power. So that is a problem, and drives are the same. So if you use a USB serial ATA adapter and power it from an external power supply, it is often the case that these power supplies that are bundled with the adapter actually only supply 2 ampere at 12 volt, and that might be not enough for the drive. So this is one thing that often leads to instability during the writing process.
Thanks a lot.
Right, if there's no more questions, I think I'll say thank you very much, Steffen, for fascinating talk.
Yeah, thank you for having me. This is probably the only good thing that came from this COVID stuff. So I always planned to visit user group meetings in the UK, but my job actually was more concentrated on Germany, and not much free time available. So it never really worked out. So nice to have the opportunity now during this crisis.
Yes, it's definitely one of the good things that's come out of it. So we've been able to speak to people, the RISC OS users more widely spread around the world. It's been really good. Thanks
yeah,
again.
I mean, if we do local RISC OS meetings in Germany, you have to organize it really well that once a year more than 4 people will turn up. Yeah, so this is really, really completely different. And now speaking to so many people in the same RISC OS mood.
Right.
Thank
so
you.
just
Thank you.
open it all up for any general chat now. The meeting will be open for as long as people hang around, as we may have noticed in previous months when we finished sometime in the early hours of the morning.